सो गुड इवनिंग एवरीवन, आई होप यू ऑल आर डूइंग वेल। और आज हम थर्मोडायनेमिक के कॉन्सेप्ट सीरीज का सेकंड इंपॉर्टेंट कॉन्सेप्ट डिस्कस करने जा रहे हैं, दैट इज रिलेटेड टू द थर्मोडायनेमिक वर्क डन। So before starting the session, just let me know, am I audible and visible to everyone or not, so that we can start a very important concept of basic thermodynamic, जहां पे अब हम डिस्कस करेंगे। कल हमने, अगर आप देखोगे, कल का जो लेक्चर था, कल का जो कॉन्सेप्ट था, इन दैट पर्टिकुलर पार्ट वी हैव डिस्कस all about the heat transfer as well as specific heat, and today we'll try to complete entire and each and everything related to the thermodynamic work done। और उसके बाद में जितने भी न्यूमेरिकल हो सकते हैं we'll try to solve based on all the concept जो आज हम करेंगे। तो जल्दी से कमेंट सेक्शन में लिख दीजिए, am I audible and visible to all of you? Not? Yes। And this is Sonu Chauhan, I welcome all of you ऑन बायजू एग्जाम प्रेप। जल्दी से आ जाइए और कमेंट सेक्शन में बताइए, इज एवरीथिंग फाइन और नॉट? एग्जैक्टली, ओके। सो अगेन ये आपका कॉन्सेप्ट मास्टर सीरीज का सेकंड टॉपिक है। इफ यू हैव ड्रीम टू गेट 23 या फिर आपका कोई भी कॉम्पिटेटिव एग्जाम मैकेनिकल रिलेटेड से आप ड्रीम देख रहे हो, तो यस, जल्दी से चैनल पे आ जाइए और जल्दी से मुझे इन्फॉर्म करिए कि एवरीथिंग रिलेटेड टू द ऑडियो एंड वीडियो क्लियर टू यू, एंड आफ्टर दैट वी स्टार्ट द नेक्स्ट इंपॉर्टेंट टॉपिक ऑफ बेसिक थर्मोडायनेमिक, माय डियर, राइट। और इस बेसिक थर्मोडायनेमिक का जो पहला अपने कॉन्सेप्ट किए हैं, दैट इज रिलेटेड टू द हीट ट्रांसफर एंड स्पेसिफिक हीट। सेकेंड कॉन्सेप्ट की तरफ हम बढ़ रहे हैं, दैट इज related to the work done, my dear. Okay, so I think everything fine, we can start from here। आ जाइए जल्दी से और स्टार्ट करते हैं सेकंड कॉन्सेप्ट आज आपका, दैट इज ऑल अबाउट रिलेटेड टू द वर्क डन। यस, दिस इज ऑल अबाउट मी। I have 10 plus year of experience in teaching field of GATE and ESE. I have completed my master in thermal. If I'll talk about the written exam, I have qualified these GATE examination 4 times, ISRO as a scientist 2 times, NPCL, and after that GPSC class 2 officer and railway. Yes, thermal today we are going to discuss, and the important topic is work done। अगर अभी तक आपने टेलीग्राम चैनल नहीं ज्वाइन किया है, सो ज्वाइन द टेलीग्राम चैनल, जिसमें डेली आपको आफ्टर द लेक्चर पीडीएफ सारी मिल जाती है लेक्चर की, राइट। साथ ही साथ जो भी, जैसे आज हम वर्क डन के क्वेश्चंस करेंगे, देन ऑल द टॉपिक और ऑल द क्वेश्चन रिलेटेड टू वर्क डन हम वहां पे डिस्कस करेंगे। ओके नोरा, गुड इवनिंग, गुड इवनिंग। यस, और अगर अभी आप नए हो चैनल पे, आपने चैनल को सब्सक्राइब नहीं किया है, तो यहाँ पे बने रहने के लिए टिल 23 आप सब्सक्राइब कर देना। मैकेनिकल की अगर बात करने आओ तो यस, मंडे, वेडनेसडे, फ्राइडे और संडे, ये चारों दिन आपका मैकेनिकल इंजीनियरिंग के आपके एग्जैक्टली 10 बजे डेली चलते हैं। तो आपका ऐसा ना हो कि बाद में कोई कॉन्सेप्ट छूटे, रिकॉर्डिंग में जाके देखो। चलिए, सो लेट्स स्टार्ट द टॉपिक ऑफ वर्क डन। सबसे पहला टॉपिक स्टार्ट करते हैं वर्क डन का। पहले समझने की ट्राई करेंगे कि वर्क डन है क्या। ओके ग्रेट। तो उससे पहले आप मुझे ये बता दीजिए, क्लियर है ना सब कुछ? चलिए, यस सर, जब आप वर्क डन की बात करने आते हो तो थर्मोडायनेमिक, स्पेशली थर्मोडायनेमिक वर्क डन में देयर आर द नंबर ऑफ क्वेश्चन। बहुत सारे डाउट माइंड में आते हैं कि किसको थर्मोडायनेमिक वर्क डन कहेंगे, किसको थर्मोडायनेमिक वर्क डन नहीं कहेंगे। थर्मोडायनेमिक वर्क डन अगर थ्योरेटिकल क्वेश्चंस आ जाएं तो कौन कौन से क्वेश्चंस बन सकते हैं, न्यूमेरिकल हम कैसे सॉल्व करेंगे। टुडे वी आर गोइंग टू डिस्कस ईच एंड एवरीथिंग रिलेटेड टू द थ्योरेटिकल पार्ट, न्यूमेरिकल पार्ट, ऑल द डेरिवेशन पार्ट। यस, ओके। सो सबसे पहला क्वेश्चन वही है कि थर्मोडायनेमिक वर्क हम किसको कहेंगे, जो नॉर्मली आपने पढ़ा है कि इट इज इक्वल टू द फोर्स इनटू डिस्प्लेसमेंट इन द डायरेक्शन ऑफ फोर्स। क्या हमेशा ही ऐसा होने वाला है? क्या अगर ऐसा नहीं होगा तो वर्क डन नहीं होगा? अगर कोई डिस्प्लेसमेंट ना हो तो क्या वर्क डन नहीं होगा? तो लेट्स ट्राई टू अंडरस्टैंड कि थर्मोडायनेमिक वर्क डन किसको कहेंगे। जैसे एक छोटा सा एग्जांपल लिया है, यू हैव सीन द प्रैक्टिकल एग्जांपल इन इलेक्ट्रिकल फैन केस। तो इलेक्ट्रिकल फैन की अगर बात करने आओ तो आप स्विच ऑन करते हो फैन को एंड स्टार्ट टू रोटेट, और जब ये रोटेट होना स्टार्ट करता है तो डेफिनेटली फोर्स इज अप्लाइड इन द टेंजेंशियल डायरेक्शन। तो पॉइंट ये है कि अगर टेंजेंशियल डायरेक्शन में डिस्प्लेसमेंट नहीं होगा, अगर इसके ठीक परपेंडिकुलर हो, दैट इज इन एक्सियल डायरेक्शन, सो जो आपका सिंपल फॉर्मूला बोलता है दैट इज फोर्स इनटू डिस्प्लेसमेंट इन द डायरेक्शन ऑफ फोर्स, क्या इस कंडीशन में आप ये कहोगे वर्क डन होगा कि नहीं होगा? क्योंकि टेंजेंशियल फोर्स यू आर गोइंग टू अप्लाई एंड and air is moving from the inlet to the outlet, my dear. Okay. सो ये दो तीन डाउट हैं जो आपने सबसे पहले पढ़े कि किस कंडीशन पे पहले मुझे डिसाइड करना पड़े कि वर्क इज डन बाय द सिस्टम और नॉट. सो फर्स्ट ऑफ ऑल, बिफोर स्टार्टिंग द टॉपिक, लेट्स ट्राई टू अंडरस्टैंड कि कब हम कहेंगे वर्क होगा, कब हम कहेंगे वर्क नहीं होगा सर. सो पहले सबसे पहले कॉन्सेप्ट पे आते हैं कि किस कंडीशन में हम वर्क को थर्मोडायनेमिक वर्क कहेंगे. वर्क इज सेड टू बी डन बाय द सिस्टम. कोई भी सिस्टम को वर्क करते हुए माना जा सकता है when sole effect on the external to the system means sole effect on the surrounding is equal to raising the weight, equal to the raising the weight means आप किसी भी कंडीशन में वर्क डन बाय द सिस्टम कैन बी कंसिडर्ड जब हम ये कहें कि सोल इफेक्ट ऑन द ऑफ द सिस्टम ऑन सराउंडिंग इज समथिंग लाइक दिस कि वेट आपको लिफ्ट होता हुआ नजर आए. इन एक्चुअल कंडीशन इट मे बी द पॉसिबिलिटी कि वेट ना रेज हो रहा हो, लेकिन जैसे ही इसको अगर किसी इक्विवेलेंट सिस्टम से रिप्लेस कर दिया जाए तो यू शुड फील, अगर आप फील करने लगते हो कि यस वेट इज लिफ्टिंग और लोअरिंग, देन वर्क विल बी डन बाय द सिस्टम और वर्क विल बी डन ऑन द सिस्टम, राइट. जैसे इस सिंपल से कॉन्सेप्ट को जो आप अभी पढ़ के आए थे उसी को फिर से वापस आ जाते हैं उस कॉन्सेप्ट पे. बहुत लेट आए हो आप लोग. चलिए, एक सिंपल सा यहाँ पे डाउट था कि जैसे आपका फैन रोटेट हो रहा है, फोर्स इज एक्टिंग इन द टेंजेंशियल डायरेक्शन, और हमने नॉर्मली पढ़ा है जो आप फिजिक्स में पढ़ के आए थे कि सर वर्क डन इज इक्वल टू फोर्स इनटू डिस्प्लेसमेंट इन द डायरेक्शन ऑफ फोर्स. तो इस फैन के कंडीशन में कैसे उसको रिप्लेस करोगे? वर्क किसी सिस्टम से या किसी सिस्टम पे तब माना जाएगा जब एग्जैक्टली सोल इफेक्ट, टोटल इफेक्ट ऑफ द सिस्टम ऑन द सराउंडिंग इज सिमिलर टू रेजिंग द वेट. या तो वेट को रेज कर रहा हो या वेट को नीचे ला रहा हो. फैन तो कोई भी वेट को रेज नहीं कर रहा हो. क्या इस टाइम पे फैन आपका वर्क नहीं कर रहा? नहीं. इन एक्चुअल कंडीशन हो सकता है कि वेट नहीं रेज हो रहा हो, but when you will replace any system by the equivalent effect, और अगर आपको इफेक्ट रिप्लेस करने के बाद अगर आपको वेट ऊपर लिफ्ट होता हुआ नजर आने लगे, then definitely you can say कि सर वर्क इज डन बाय द सिस्टम. जैसे इस सिंपल से कॉन्सेप्ट को हम क्या करते हैं, यहाँ पे एग्जैक्ट वही मोटर है, वही आपकी मोटर है, वही बैटरी है, बट फैन की जगह हमने क्या किया, इसको एक पुली अटैच कर दिया. I replace the fan, क्योंकि इक्विवेलेंट सिस्टम बनाना है. So what I'll do, I'll replace the fan by a simple pulley. एक सिंपल सी पुली से रिप्लेस करते हैं like this. आपने इसी फैन को एक पुली से रिप्लेस कर दिया. Great. Like this. And with the help of this pulley और एक रोप की हेल्प से आपने क्या किया, वेट को यहां पे लिफ्ट किया like this. Like this. When battery will be connected, जब बैटरी कनेक्ट होगी और एग्जैक्टली आप यहां से मोटर रन करना स्टार्ट करेगी, रोटेट करना स्टार्ट करेगी, then you will say yes, this rope will move in the upward direction, this weight will also lift in the upward direction. So what meaning I am getting, in actual condition weight may not be lift, लेकिन जैसे ही आप इसको इक्विवेलेंट सिस्टम से रिप्लेस कर देते हो, अगर ये वेट आपका लिफ्ट हो जाता है, देन यस यू कैन से सिस्टम इज डूइंग सम वर्क. एंड दैट इज द रीजन इन सिंपली कंडीशन यू कैन राइट दैट वर्क डन बाय दिस थर्मोडायनेमिक सिस्टम will be equal to W, that is weight. I will write this by force, so W and W will be the same, so that is W into dx, my dear. यहाँ पे आप सिंपल कह सकते हो कि जो वर्क की वैल्यू होगी that will be W into dx, करेक्ट. आफ्टर दैट उसके बाद एक दो क्वेश्चन और यहां से आता है, and W will be replaced by F. This W will be replaced by F. F into dx, correct. Now after that, if I'll ask a simple question that what is the work done by this entire system, यहाँ पे एक रेड यहाँ पे जो बाउंड्री यहाँ पे बना दी है, अगर एक सिंपल मैकेनिकल इंजीनियर से पूछा जाए कि व्हाट इज द वर्क डन बाय द सिस्टम, तो हम सिंपली कहते हैं कि सर इट विल बी द सॉफ्ट वर्क और इट विल बी द मैकेनिकल वर्क। या तो ये सॉफ्ट वर्क होगा या सिंपली आप इसको मैकेनिकल वर्क कहोगे। क्यों? क्योंकि एग्जैक्टली आप सॉफ्ट तक को सिस्टम एज्यूम कर रहे हो, सिस्टम एज्यूम कर रहे हो, एक्सटर्नल टू द सिस्टम सराउंडिंग कंसिडर कर रहे हो। तो व्हेन यू विल कंसिडर दिस बाउंड्री एज अ boundary of the system, then work will be considered as a mechanical work. At the same time, if I consider the boundary between, so this one, it is nothing but mechanical work done. And if I'll consider what is the work done between the battery and motor, my dear, so उस condition में क्या होगा? आपके इलेक्ट्रॉन फ्लो करना फ्रॉम द बैटरी टू द मोटर, and when your electron are flowing, then flow of electron is nothing but this is the part of electrical work. And one more thing, at the same time, if I'll consider that what is the total weight of the system when this is considered as a total system, जब ये complete system को आप इसको complete system मान लिया जाए like this white color dotted line, that is nothing but a boundary. अगर इसको आप बाउंड्री कंसीडर कर लेते हो, देन इन दैट कंडीशन व्हाट विल बी द वर्क डन, उस कंडीशन में क्या वर्क डन होगा? तो यस यू विल से इफ नो सिस्टम इज देयर और नो इफ योर सिस्टम इज नॉट इंटरेक्टेड विद, सिंपली मैं कह रहा हूं यहां पे यस ओके एसके ओके ग्रेट. सो सिंपली इफ आई आस्क, I'll discuss 2-3 things SK till now. One thing we have discussed, how can we feel that work is done by the system or on the system? So first point is, whenever weight is lifted by the effort of the system, then you will say work done on by the system. In actual, weight may not be lifted, but its equivalent effect is something like this. Then you can say yes, work is done on the system. Let me come back to the reality. We have discussed a very simple problem in the first of the slide. On the first of the slide, we have discussed a simple problem. When it is an example of a fan, then motor is rotating. And when your motor is rotating, then fan is also rotating. So when I say the sole effect of the system on the surrounding is lifting the weight, then in actual condition it is not lifting. But when I have just replaced the system by the pulley, then I am feeling that yes, system can lift my weight with the height of dx. That is the reason I can say work is done by the system. One more point. After that we are going to discuss, is work done depend upon the boundary or not? Yes. Till now we have proved, you are just a little bit late SK. Till now we have proved that when I am going to change the boundary, the amount of the work or the type of work is going to change. For example, if I consider the boundary between the motor and the pulley, then we all say, sir, it is the part of mechanical engineering or mechanical work done. When I have considered the boundary between the battery and motor, then it is the flow of electron, then this is the electrical work. And when I'll consider the total boundary of the system, like there is the fan in this room and I have considered the total room as a system, I have just drawn all the boundaries of the system. So can you write the answer? What is the work done by the room? Right now for us, work done by the room will be 0. Very good. Work done by the room will be 0. That is the reason we can write that work done is a boundary phenomena. Very good. Work done is a boundary phenomena. This is the first concept. It will depend upon the boundary. So before starting to write the answer of any question related to the work, first of all you need to define system or boundary of the system. Great. One more question. If I will cut off this connection between the battery and motor, if I cut off this connection between the motor and battery, no connection between the battery and motor, my dear, can you say work is done by the system? Any part of this thermodynamic system, say yes or no. Can you all say that work is done any part of the system? Answer is no. Answer is no. But again, the same energy is stored into the system. The same energy is stored in any part of the system. That is nothing but battery. So what conclusion we are getting from the second point? Work will take place only. Work will take place only when there will be a process. When there will be a transient form of energy, not stored form of energy. So second important point, I can say that work cannot be stored. That is the reason work is not the stored form of energy. There are always two type of energy. One is stored, like internal energy is the stored form of energy. Yeah, Raj, just 10 to I think 15 minutes we have invested to understand the topic of work done by the system or on the system. How can I say that work done will be work done by the system or on the system? Work done is zero or non-zero. First point we have derived. Second point we have derived that work done is a boundary phenomena or not. And third point we have derived that work done, how work done is written like this: force into displacement in the direction of force. And fourth point, just right now I have just concluded with SK and you all guys, that work done cannot be stored form of energy. It will take place when energy will transfer from one particular point or one particular state to second particular state. So that is the reason we have also written that work done is a boundary phenomena, and with the boundary phenomena, work done is transient form of energy. Work done is transient form of energy, my dear. Okay, two theoretical questions are asked number of time. Work done is path function, point function, boundary phenomena, transient form of energy, stored form of energy. These are the theoretical type of question which are generally asked in number of exam like SSC or like state PSC or like UPSC theoretical exam. Okay, great, good. The meaning of transient, the meaning of the transient form of energy, that you can't store the work. The example I have taken simple: you disconnect the battery from the motor, then in that condition no process will occur, my dear. When no process is going to occur here, then energy is stored within the battery, but that is not a work done. That is chemical energy. So yes, you can store the chemical energy, you can store the internal energy, but you can't store the work done. That is the reason work done is transient form of energy. Clear? Okay, great. After that, let's try to understand that what is the work done for a closed system. What is the work done for a simple closed system? Sir, right now we are going to discuss that the gas is filled in this chamber. Very high pressurized gas is filled in this chamber, and a stopper is attached to stop the motion of the piston cylinder arrangement. So at this time, the pressure of this gas, my dear, is P. Very high pressure H compared to atmosphere. Volume of this is V. And after that, what I'll do, I will just remove, or I'll just remove these all the stoppers, and after that I'll allow to move this piston from this particular location to this particular location. First of all, this is completely closed piston cylinder arrangement, my dear. So if it is completely closed piston cylinder arrangement, then definitely it is example of the closed system. So one thing, whatever we are going to driving, whatever we will get from this entire discussion, that will be the work done only valid for the closed system, because always right now in this situation we are dealing with closed system. So if I will write that, sir, what work done we have studied, if the gas apply the value of force F on the piston, then force into displacement in the direction of force. Right now we have proved that force into displacement displacement of the gas in the direction of force, we have just proved it till now. Okay, so in this case, If I write that, sir, pressure applied on the piston is P. So again, can I write that pressure is equal to force upon P area, my dear. With the same point, can I write that force is also equal to pressure into area. So at the same time, can I write that work done is equal to P into A into dx. Sir, here from one particular point to two particular point, cross section area is constant. So can I write this is nothing but work done of a closed system, that is P into dV, my dear. P into dV is the work done of a closed system. But after that, I'll ask a very important point. Sir, this work done is proved for a closed or for an open system? Closed system. When you are going to drive this entire derivation, have you considered this process, SK and Raj both? Have you considered this process is a reversible or irreversible or any process? Any one of you? This you have converted in the, or you have assumed that this is the example of reversible process, irreversible process, or both. What answer you are getting? It is valid for reversible, irreversible, or both. Very good. Sir, what if it is open system? Definitely answer will change. Answer will change. One by one we will cover both the steps. Let's try to discuss first close, and after that we will discuss open. Sir, according to SK, it is valid for any system. Okay, just a minute. You have considered that inside pressure in this case is P, my dear. Inside pressure is P. Great. And when you are writing that F is equal to P into A, so this you have considered what internal pressure of the gas is applied on the piston. The total force is utilized to do the work done. Total force is utilized to do the work done. So at any point, have you considered that there is some loss of the force due to the irreversibility, due to the friction? No, we have never considered. We have written whatever inside pressure is there, this is completely converted into the mechanical force, and this mechanical force is fully utilized to do the work done according to the formula. This force is completely utilized to do the work done. It means you are not going to consider the friction loss. That is the reason this is the work done for reversible process, but only for the closed system. Again, I'll come on the same slide after discussing a very important point. So, if I'll discuss the same problem in 2D, then let me draw the same problem on PV diagram. Pressure and volume, these both the parameters are changing. So right now it was the first location of my system. My thermodynamic system, it was the first location. When it is allowed to expand, then second location was this one. So if I'm not wrong, then at this particular location pressure was P1 and volume was V1, my dear. Yes, okay, no issue. SK, right now you need to understand, if you write the answer wrongly, it's not a bad thing, but right now you need to understand this point. Sir, you will tell me, when I am moving from 1 to 2, can I write, sir, pressure decrease but volume increase. So if I will draw from this particular point to this particular point, then pressure is decreasing, my dear, and volume is increasing, my dear. Absolutely right. And this value is P1, nothing but P1, and this value, my dear, is nothing but P2, and this is V1 and V2. Come back to the point. Sir, what is the work done? We have proved that work done, we have proved it is equal to P into dV. If I want to calculate total work done between 1 and 2, my dear, total work done between 1 and 2, I will do the integrate from 1 to 2, that is P into dV, my dear. P into dV. Just for 1 minute. If I will calculate the area of this small member, then area of this very small member will be equal to P into dV. And if I calculate the total area between 1 and 2, it will be nothing but integration from 1 to 2 and into P into dV, my dear. What point we all are getting, that right hand side of both the equation is absolutely right. But left hand side in equation 1 is the work done, and in equation 2 is the area of the PV diagram. So if you don't mind, can I write that work done is the area of PV diagram, but about volume axis only. Till now we have proved this point. Work done for a closed system is area of the PV diagram about volume axis only. Is it clear, everyone? Is it clear to everyone? Raj and SK. Raj and SK and you all. Nora, it's clear to everyone or not? Yes? Great. Okay, very good. So what exactly meaning of this statement we are getting? That work done is the work done between 1 to 2, my dear. It is area of PV diagram. Area of PV diagram, but about volume axis only. About volume axis only. Now after that, what exactly I'll tell you. You will feel that, sir, right now you need not to do anything. We all are able to solve any problem of the work done. A very important point I am going to tell you. And after that you feel, sir, no need to discuss any process. We are able to calculate the work done for any given, any known or unknown process. But these all the things whatever we have written, let me clear, these all points are valid for the reversible process and closed system only. If we will talk about the open system, my answer will change. But we are not disturbing the closed system work to introduce the open system in between. Whenever closed system will be over, we will introduce the open system. Great. Otherwise, entropy will increase. Day after tomorrow, we will discuss the topic of entropy. Yes, sir, in this case. In this case, work done is nothing but area of the PV diagram about the volume axis only. Yes. And this is all about the closed system, not all about the closed system, not about the open system, my dear. Yes. Today we are going to discuss the problem. Raj, we have the number of problem after the session, because after 10 to 15 minutes you will be able to solve any problem related to work done. If it is the problem related to closed system, when you will say, sir, we are absolutely confident we can solve the problem, after that we will come on the topic of problem. Yes, come back. Sir, there is the process. Like, yes. This one is the process. 1 to 2. 1 to 2 is the process. And Vacha come and ask to you, what is the value of the work done? So if you study the mechanical in general way, then what you will say, sir, I don't know the formula, because there are the 5 process. If a formula of these 5 process are known to me, then only I can give you the answer. No. After that, we have proved a very important point, that, sir, to check the work done of any process, I need not to introduce the formula. I know very important point. If the process is reversible, check the area about PV diagram. Check the area of the PV diagram about the volume axis. So yes, sir, this area is nothing but this area, my dear, is nothing but the area of work done. Yes, absolutely right. So if I'll write that work done in process 1A2, it is equal to the area under 1A2. Absolutely right. But again come and he ask, what is the next process? 1V2. And if I ask next, sir, what is the work done, then you all will say, sir, calculate the value of the work done about 1V2 then you need to calculate the area about 1v2. Are you getting? Area of both the process are same? Not same. Area of 1A2 मैथमेटिकली यहां से प्रूव हो रहा है, it is not same. So if it is not same, then how can you write that work 1A2 is absolutely equal to work 1V2? It is never possible. So what you are dealing with right now, मुझे पता चला कि वर्क डन एक्चुअल में पॉइंट पे तो डिपेंड कर ही रहा है, इनिशियल एंड फाइनल, बट इट इज ऑल्सो डिपेंडिंग अपॉन द पाथ. आप कहां से आ रहे हो, किस पर्टिकुलर पॉइंट से आ रहे हो, इस पे भी डिपेंड कर रहा है, इस पे भी डिपेंड कर रहा है. सो कैन आई से एब्सोल्युटली राइट, कैन आई से वर्क डन इज ऑल्सो द पाथ फंक्शन माय डियर. पाथ फंक्शन का मतलब यह है जिस पॉइंट से आप गुजरते हो, जितने पॉइंट से आप गुजरते हो, हर पॉइंट पे वर्क डन डिपेंड कर रहा है, हर पॉइंट पे वर्क डन एग्जैक्टली डिपेंड कर रहा है. और जब जब आपका फंक्शन बहुत सारे वेरिएबल का फंक्शन हो जाए, जो आपको साफ नजर आ रहा है, दैट इज द पाथ फंक्शन. उसको अगर मैं गलत नहीं हूं तो मैथमेटिक्स में आपने एक बहुत इंपॉर्टेंट टर्म से लिखा होगा, दैट इज नथिंग बट पार्शियल डेरिवेटिव और इनएग्जैक्ट डेरिवेटिव, इनएग्जैक्ट डिफरेंशियल माय डियर, differential. Very good, great. Yes, SK. Inexact differential. 5 important point we have derived. First important point, work done. Exactly. First important point, work done is the area. Second, work done PV diagram. Work done is a boundary phenomena. Work done is a transient form of energy. Work done is a path function. Work done is inexact differential. And whenever it is inexact differential, it can never be written as dw. Inexact is also written either like del, or either like this del, or either like this del. We have written the value of the work done wrongly, the sign or symbol of the work done wrongly. Let it correct. Let's correct this. Are you not feeling this must be del, my dear? यहाँ del होना चाहिए. Are you not feeling that this must be del? Yes, क्योंकि अभी मुझे पता चला. This is the value of del. Right now I have proved this is the value of del. Not a point function, it is a path function. But after all, sir, whatever we have written, you can check. Path function, inexact differential, boundary phenomena, transient form, and it is not a property or a point function. क्योंकि अगर ये path function है तो point function नहीं हो सकता. Great. Up to this, is everything clear? Sir, now I am feeling the thermodynamic. Okay, thank you. Just write in the comment section, up to this point, is everything clear, my dear? I'm waiting for your answer. Any issue? Yes. Okay, good. Raj, no issue? Can we move forward? Okay. So Raj, let's try to solve, or let's try to discuss few problems. So I have proved, sir, or we have discussed that work done is nothing but it is the area of, just try to feel, it is the area of PV diagram. It is the area of PV diagram, my dear, about, very good, about volume axis. Volume axis. Yes, absolutely right. After that, are you not feeling, if I want to check the work done for any reversible process in closed system, then after that it is not a problem of thermodynamics. It's a problem of mathematics. Because in the topic of integration, if you are able to recall that point, in the topic of integration, we always calculate the area like this. That is either x into dy, my dear, from 1 to 2, or it will be y into dx, my dear. like 1 to 2. Similarly, we are getting here, you are not feeling this point. Similarly, we are getting here that P into dV, and 1 to 2 is nothing but it is the work done. After that, it is the problem of mathematics, not thermodynamic. So one thing is clear. Sir, if initial state is known to me, first point. Second, final state is known to me, and relation between the pressure and volume known to me, I can give you any answer. Either this process is known to me or not, either this process is including these 5 important processes, that is the isobaric, isochoric, isothermal, adiabatic or polytropic. If I know these 3 important things, first, location or state of initial point, final point, and after that, relationship between the pressure and volume, then I'll substitute the value in the integration. I can find the work done in any arbitrary process, either 5 known process or any unknown process. Great. Good. Let's try to discuss first what is the work done for 5 known process. After that, we try to solve for 5 unknown process. Sir, if I calculate, or if I want to calculate what is the work done in isochoric process or constant volume process, sir, what will be the area of this entire diagram about volume axis? You need to find the area. Area, it will be nothing but that is P into dV, my dear. So in this case, P into dV will be nothing but it is 0. So work done in isochoric process is 0. And in this case, sir, work done is equal to force into displacement. We use the general equation, we get the work for open system and closed system. No. For closed system, we are using only right now. But for the open system, equation change only. Okay. Great. Right now, we use only for the closed system, not for the open system. At the same time, if I calculate the work done 1 to 2, work done 1 to 2 for isobaric process, my dear. Again, I have to do the integration from 1 to 2. That is P into dV. Then one thing is clear from the diagram. If it is the isobaric process, then pressure is constant, my dear. So I have to integrate only the volume, that is from V1 to V2, my dear. So if I'll write the value of the work done, that will be equal to P into V2 minus of V1 for an ideal gas. Just a minute. Sir, at the same time, from the ideal gas equation, can I write that work done or PV is equal to MRT2 minus T1. So this is also the work done formula. This is also the work done formula for isobaric process. This is the isobaric process. This is also the isobaric process. Correct. After that, if you want to discuss what is the work done for isothermal process, then again you know that P1 V1 is equal to P2 V2 is equal to PV is equal to constant. Yes. So if I do the integration, can I write the direct answer? You know, you only need to do the integration. What will be the answer? P1 V1 ln V2 by V1. And for this equation, this is also equal to P1 V1 ln P1 by P2, my dear. सारे पॉइंट्स लिख चुके हैं. वर्क डन. ये टास्क मैंने आपको दिया कि आपको बस इंटीग्रेशन करना है इस इक्वेशन में सब्स्टिट्यूट करके. एंड आई एम वेरी श्योर आप उस कंडीशन में तो आ चुके हो मैथमेटिक्स पढ़ के कि सर इंटीग्रेशन तो हम कर ही लेंगे. What I'll do, I'll substitute the value of P, that will be C by V, my dear. Substitute करेंगे यहाँ पे C by V, you will get the answer. Great. Now after that, what is the work done of adiabatic process? What you all are doing in adiabatic process? Adiabatic process में भी हम actual में work done ही calculate कर रहे हैं like this. So if I'll write the general formula, then general formula we have discussed 1 to 2 will be equal to integration of P2 dV. So from here I can easily write that work done will be equal to, right now I am also writing the direct formula. You will do the integration so that we can conclude these all the points. That is P1 V1 minus P2 V2 divided by gamma minus 1, and this is also equal to MR of T2 divided by gamma minus 1. Okay, this is also the work done for adiabatic process. This is also the work done for adiabatic process. And let me clear, आपने यहाँ कुछ किया नहीं है, आपने सिर्फ ये एरिया ही कैलकुलेट किया है. At the same time, if we'll calculate the area for the polytropic process, PV raised to n, sorry, not quasi-static process, PV raised to n. So in this condition, I will write that work done will also again, कल ही हम इसको लिख के आए थे इसके, we have written the same point yesterday. So this value will be equal to P1 V1 minus of P2 V2 divided by n minus 1, and P1 V1 we have already written MR T1 minus of T2, my dear. So this value is equal to n minus 1. N minus 1. Okay, great. This is the work done for polytropic process. This is the work done for polytropic process. Great. Sir, ये पांचों आंसर आ चुके हैं. All the numerical formula of 5 known process is known to me. The next question after that, if I'm not able to know these 5 process, or my process is other than these 5 process, then what is your answer? Sir, for the 5 process, we all have the formula. No issue in it. But if we have any process other than these 5, then what should be your answer at that time? Sir, give me the relationship between the pressure and volume. Give me the diagram between initial and final state. I'll give you the answer. I'll give you the answer, my dear. Great. So in this case, if nothing is known, and let me clear, in all these 5 formulas, you have done nothing. You have only calculated the area when relationship between pressure and volume already given to us. For example, in adiabatic process, relationship is known to me. In polytropic, known to me. Isothermal, relation between pressure and volume known to me. And that is the reason you are able to calculate the area. So after that, you will focus on one particular point, that if the process are these 5 process, apply the direct formula. And if the process are not these 5 process, then establish the relationship first between pressure and volume. For example, tomorrow or today even, there may be the problem like this. There may be the problem like this, that is pressure and volume. Cycle is reversible, my dear. Cycle is reversible, but in this process is reversible. And in this process, the volume of this particular point, my dear, is 5 meter cube. And the process of or volume of this particular point is 1 meter cube. And pressure of this particular point is 4 kilopascal. And pressure of this particular point, my dear, it is nothing but 100 kilopascal. Now, if the question will be asked to you that what is the value of the work done in this process, can you write what is the value of the work done in this process? So as an engineer, what exactly we will do, this V1 volume is 1, my dear, and this V2 volume is 5. What is your answer? What is your answer? Any one of you can give me the right answer. Any one of you can give me the right answer. What is your answer? The area under the process is known as work done. Yes, write the answer. Write down the answer first. Very good, very good. This is 1000 kilojoule, my dear. Absolutely right. This is 1000 kilojoule is absolutely right. Great. Okay. After that, let me ask a very simple question. Sir, this one is a PV diagram. This one is a PV diagram. Correct. After that, you draw a process like this. One, or just a minute. You draw a process like this, my dear. 1 to 2. That is isobaric process. You don't stop at this point. You draw one more process like this. That is PV raised to gamma is equal to constant. Okay. And you draw this process also. Like this. Are you getting? I am talking about thermodynamic cycle. Right now we all are dealing with the thermodynamic cycle. Here. So if I'll ask, what is the net work done in this thermodynamic cycle can be achieved, then what you will do? How will you calculate the work done? First of all, you will calculate the total net work done of this cycle will be the value of the work done 1 to 2, algebraic summation 1 to 2 plus of 2 to 3 plus of 3 to 4. This will be the net work done, my dear. This will be the net work done. How will you calculate the answer? You will calculate the answer like this. Yes, HK, SK. You will calculate the answer like this. First of all, you calculate the area under this one. You calculate the area under this one. That answer will come positive. Because V2 is greater than V1. That answer will come positive. Then you will calculate the area under this, my dear. Area under this. Then again, you will get the positive answer with any numerical value. If it is the adiabatic process. Great. After that, when you will compress my system, when you will compress my system, then you will calculate the area under this, my dear. And I am very sure that this value will be the negative. This value will be the negative. Are you not getting that this will be the net area I am talking about? This will be the net area I am talking about. Yes or no? Rohan, this will be the net area. So can I write in a cycle, in a thermodynamic cycle, net work output is the area of cycle on PV diagram, my dear, on PV. So if you will have any cycle, then you need to focus on the area of that cycle. You will get the work done. So my dear, one question I'll ask at last. In any arbitrary cycle, if work is asked to you, what you will do? You will focus on the area of this closed cycle. Very good. If in any thermodynamic process, if work is asked to you, what exactly you will do at that time? You will always focus on the area of PV diagram about volume axis. Let me give you one more star point, and after that you will start to feel, sir, right now it was the positive. It was also the positive and this is negative. Can you give me the answer? What is the net work done? Total net work done will be the positive or negative, my dear? Total net work done will be the positive or negative? Sir, positive. What is the meaning of the positive, Rohan? What is the meaning of positive? Always positive means you are producing the work. Work is done by the system. And what is this type of the cycle, my dear? This is nothing but this is the clockwise cycle. So can I write at last point? If the cycle is the clockwise cycle on PV diagram, then work will be always produced by the system. Work will be always developed by the system. That is the reason that all the clockwise cycle are known as power producing cycle. Very good. Power producing cycle. Power producing cycle. Absolutely right. At the same time, if I'll reverse the cycle, then my dear, this will be the negative, this will be the negative, but this will be the positive, Rohan. And when this will be the positive, then at that time, net work done will be negative. And if net work done will be negative, what is the meaning of this? You have to invest the work done in the cycle. Are you getting or not? You all are getting or not? The net work done in that situation will be done on the system. और जब जब वर्क आपका सिस्टम पे होगा, दिस इज द एग्जांपल ऑफ पावर कंज्यूमिंग और रेफ्रिजरेशन साइकिल. Now you need to follow all the power plant cycle. You need to go through all the refrigeration cycle. और किताबों के पन्ने पलट के देखना, all the refrigeration cycle are anti-clockwise cycle on PV diagram, power absorbing, and all the power producing cycle are clockwise cycle on PV diagram. So how to calculate the value of the work done in a cycle we have discussed. How to calculate the value of the work done in a process we have discussed. If we have 5 process, we can calculate. These non-5 process are given to me. I can calculate with the help of 5 different formulas. Very good. If there is any process which is other than this 5, what I'll do, I'll establish the relationship. I'll calculate area under the PV diagram. That is the work done for closed system undergoing a reversible process. Let's try to apply these all the concept in the number of numerical. And most of the question I have taken from the GATE exam, so that you can get the idea that are we able to solve the question or not. Yes. Let's try to discuss few problem, my dear. This is the first problem. GATE 2011 1 marks problem. I think this point I need not to discuss. Heat and work, these both are the path function. Heat and work are both example of the path function. Great. After that, yes, solve this question. A piston cylinder device initially contains 0.4 meter cube of air at 100 kilopascal and 80 degrees centigrade. The air is now compressed to the volume of this one in such a way that temperature remain constant. Isothermal process. Isothermal process. Rohan SK, go to the back slide. Check the value of the work done in isothermal process. First, if you want, I can draw the process on PV diagram. On PV diagram, I can draw the process, my dear. This is the example of compression process. Yes. Compression process. Like this. And like this. P1 is given to me. V1 is also given to me. What is the formula we have studied? Work done in isothermal process. We have written a very important formula, that is P1 V1 ln V2 YV1. V2 YV1. Volume is compressed up to the half. Not up to the half, sorry, 0.1. So P1 100 kilowatt, V1 0.4, ln and V2 0.1 and this 0.4 means 1 by 4. Can you write the answer? Rohan, can you write the answer? Let me cross check your answer. Let me cross check your answer. ln 4 or 1 by 4 ln of answer multiply by 0.4 multiply by 100. Are you getting 55.45? All of you are getting minus 55.45 kilojoule. What is the meaning of minus? Because it is the example of compression. So if it is the example of compression, then work you require to done or to do on the system. To do on the system. Work will be done on the system. Yes. If you are getting this answer, all of you, then absolutely correct, right answer, my dear. Let's try to discuss, try to solve one more question. Yes. 1 kg of air. Good, good, good. Great. Work is supplied to the system or work is added to the system. Yes. 1 kg of air initially at temperature of 127 degree centigrade, expand reversibly at constant pressure until its volume become double. If gas constant is 287 joule per kg of Kelvin, the magnitude of the work done is very important question. Yes, SK. I am waiting for 1 minute and after that I'll start. Yes. 1 kg of air initially at a temperature of this one and volume is somewhere V1, pressure is P1. Constant pressure पे जब तक volume double नहीं हो जाता, volume is double. If pressure is constant, volume is double, then what will be the effect on temperature? Temperature will also double. A small hint I have given to you. So in this case, what is the work done? You need to find, my dear. In the case of isobaric process, it is the isobaric process now. So if volume is double, then pressure is the constant and diagram will be something like this. This is 1 and this one is 2 and this is the process something like this. This is the process something like this. You can do one mistake here. You can do one mistake here. That is V1, this one is V2 and this one is pressure. So I'll write total value of the work done is equal to P V2 minus of V1, my dear. P, what is the P? Not given to us. Then we can calculate M into R into T2 minus of T1. Oh my God. It is in the term of T1 and T2, not in the term of P1 and P2 or V1 and V2. Now we can calculate the temperature T2. So if the volume double, then temperature will also double because we have already studied P1 V1 divided by T1 is equal to P2 V2 divided by T2, my dear. So if the pressure is constant and volume become double, then temperature will also double. But in this case, what is the value of T1? T1 is 300. 127 will not double. 300 will become double. So in this case, I'll write 600 Kelvin. 600 Kelvin. So when I solve this problem, M is 1 kg, this one R is 287 and T2 minus T1 is 300, my dear. Then you will calculate the answer. What answer you are getting? That 300 multiplied by 287, it is in kilojoule. In kilojoule. Yes, what answer you are getting? What answer you are getting? R is given to us. How are you getting 114? Okay, temperature is 400. Sorry, temperature is 400. Sorry. And double of the 400 is 800. Yes, yes. It is a mistake. Yes. This one is the 400, my dear. So after that, yes, answer will be 114.8 kilojoule is absolutely right answer. Let's try to discuss one more problem. GATE 2009. GATE 2009. The frictionless piston cylinder device. It means it indicates that process is the reversible process. It expands quasi-statically at the constant temperature, isothermal process, to the final volume of this one, my dear. Initial pressure given, initial volume given and final volume given. Then you need to write what is the value of the work done in isothermal process. This is equal to P1 V1 ln V2 y V1, my dear. When I solve this equation, P1 is 800 kilopascal, V1 is 0.015 and ln this one is equal to 30 divided by 15. What answer you are getting? What answer you are getting? This is ln 2 multiplied by 0.015 multiplied by 800. Are you getting 8.317 or am I only one who is getting this answer? क्या आपका भी यही आंसर आ रहा है या सिर्फ मेरा ही आंसर आ रहा है? Write in kilojoule. All of you are getting the answer like this. Yes or no? Great. ये तो कुछ जो प्रॉब्लम लिए थे एग्जाम्पल के लिए वो थे। उसके बाद अगर कोई भी प्रॉब्लम आ जाए, अगर आपको रिलेशन पता चल जाता है, यू आर इजिली एबल टू कैलकुलेट द आंसर, बड़ी आसानी से कैलकुलेट कर सकते हो आंसर को। वेरी गुड एसके, वेरी गुड, यस। सो दिस इज ऑल अबाउट द टुडे सेशन। आई होप मैक्सिमम नंबर ऑफ प्रॉब्लम रिलेटेड टू द वर्क डन इज क्लियर टू यू। बहुत सारी प्रॉब्लम, बहुत सारे जो डाउट होंगे, वर्क डन एटलीस्ट ये हो गया होगा कि जितना ज्यादा अब हम प्रैक्टिस करेंगे, नंबर ऑफ क्वेश्चन को सॉल्व करोगे उतना ज्यादा आएगा। जब साइकिल आए तो साइकिल का एरिया, प्रोसेस आए तो प्रोसेस का एरिया। बट अगेन यहां तक अभी क्लोज क्लोज वर्क डन के लिए, क्लोज सिस्टम के वर्क डन के लिए हमने डिस्कस किया था। ऑलरेडी पीडीएफ आई हैव शेयर्ड विद यू ऑन माय टेलीग्राम चैनल, जिसमें आपके लास्ट 20-25 ईयर के क्वेश्चन जो एग्जैक्टली सिर्फ वर्क से रिलेटेड हैं वो हम कर चुके हैं। टुमारो इज वीक ऑफ, इज माय वीक ऑफ। डे आफ्टर टुमारो विल बी द टॉपिक ऑफ एंट्रोपी माय डियर। फिर से वही एंट्रोपी का टॉपिक करेंगे कल के बाद, and I'll try to explain the topic of entropy in more practical way rather than the numerical way. फिर उसके बाद भले आप फॉर्मूला लिख सकते हो। So day after tomorrow exactly on 10 PM your lecture will be related to the entropy my dear. So I hope आपको दो टॉपिक यहाँ से बिल्कुल अच्छी तरह से क्लियर हो गए होंगे। One is related to the heat transfer, second is related to the work transfer. Okay. So if you have not subscribed the channel till now, do the subscribe. And after that, if you have not liked the session, and like the session and join the telegram. Okay, thank you all. Take care. Bye bye. Good night. और बस इसी तरह से आप पढ़ते रहो एग्जैक्टली। और आपने जो ड्रीम देखा है, देखो देर बहुत ज्यादा लग सकती है, बहुत ज्यादा टाइम लग सकता है, क्योंकि 1-1.5 साल बहुत दूर है अभी। बस थकना नहीं है। जिस दिन आप थक के हार मान जाओगे, उस दिन आगे दिन आपको मन ही नहीं करेगा पढ़ाई के लिए। सो जस्ट फोकस ऑन योर ड्रीम एंड डेफिनेटली यू विल अचीव योर ड्रीम वन डे। थैंक यू। गुड नाइट। गुड नाइट एवरीवन। थैंक यू। यस।